transactions, and its APIs facilitate eligibility checks, claims, appointment scheduling, payment optimization, patient identity, pharmacy benefits, and other business processes. Ted has worked for Apple, Microsoft, and has held instrumental roles in several startups. He's on the IAB for the University of South Carolina Computer Science Department, as well as the Center for Intelligent Systems and Machine Learning at the University of Tennessee. Please join me in welcoming Ted Tanner.
All right, good afternoon. So we had a show of hands, a lot of oil and gas. How many health folk in the crowd? A couple. How many people have ever been to the doctor? Yeah, they call it health, not wellness, right? So what we do is we're trying to optimize the business of health. And when I got into this about 5 years ago, coming from a machine learning, signal processing, and kernel background, I was aghast at the complexities. Which way does this work? Nope, that's why I was wondering. Did it go dead?
Try this.
All right, I'll just sit here and do it. All right, there you go. So I started thinking about the entire problem set of this area and the reason that none of these organizations would actually talk to each other. And being that we're now in a blockchain sort of mind, I pulled this from 1997, where most of the developers weren't even born yet, probably. And I thought about it, and I said, why can't we just get along? Well, my data is my data, and it's not your data. That's the main problem with all this stuff. And nobody really agrees on what to do with the data, but it's your data, the consumer's data, correct? So think about that as I go along. And we think that identity is extremely important in the paradigm for the business of health as well as fintech. So if you think about it, you have four identities. You are born. Let's hope you are born. Your parents love you. And then you have a bank account. And then you have some sort of health ID. And then a long time in the future, you have something called a death certificate from womb to tomb. Those are your four IDs. So what we set out to do was build a set of applications. And we said, okay, in 2011 when we founded PokitDok, I said, let's put it on the chain. Well, the health industry couldn't even spell API at that point. I mean, literally, it was like, oh, there's an app though. And I said, okay, let's take a crack at an enterprise application. So we have something called patient access. The patient has to get access, right? And then we have plug and play applications. In the health world, I also found out that the term clearinghouse is an oxymoron. Even worse than the financial industry. There is nothing clear about a clearinghouse in the health industry. You send your eligibility and your claim information out to somewhere out there, and it comes back in the AR windows like 180 days, right? And scheduling. I would love an open table thingy for health, right? So that's currently the architecture. And as we know, and what I just explained, those are the silos. And literally, I mean that in the strictest sense. There are companies solely specified and compete in those verticals that are behind me right now. And they will not talk to each other because their data is their data, and it is not your data, and it sure isn't my data. So what we did was we said, hey, let's go build that stuff and put appies around it. That's the funniest term I've ever heard. Hey, y'all have an appy? No, yeah, we have an appy. So provider search. One would think that Google solved that. Well, provider search is extremely difficult. We update our index of about 4.6 million providers every month. and we have to go through some extreme identity resolution. Provider search is a subset of identity. Is that provider who they say they are and the provenance of said data, correct? And the next thing is transparency and pricing. When we set out to build this company, and the reason I'm setting this up is because I'm getting ready to talk about the computation of the smart contract and how we're doing it in a non-Turing sense. So bear with me. Somebody said, well, I wonder how much that cost. And they said, nay, that's illegal. Now, would you show up to get your car fixed or your body fixed, as we do now, and we go get it fixed before we know how much it cost? And they told us it was illegal. I said, sign me up for that one. That's going to be fun. We have about 10,000 cash prices across 48 urban areas for the top 50 non-acute prices. We have a probability distribution function of all computed prices for those. We even have the price down to the CPT code, down to the GeoZip in every area. Think about that. And you say, man, I want that, right? Okay, you don't even need a blockchain for that. I'll just give it to you. Excel spreadsheet, right? What's next on the list? Identity management and scheduling. Why is scheduling and identity management together? Well, Jane Doe is at that place. We must know Jane Doe is at that place with that provider. Think about it. The identities are now folding over, right? Scheduling is, there's this word called interoperability. It's always funny to me in health that people have these titles called VP of Interoperability, and they say, I've never seen this stuff work. Well, where's your title? It's job security, right? The media industry, I worked with MPEG for several years, embedded in other areas. They solve the interoperability solution very well, as I might add. We are now interoperable across 31 EMRs under one REST endpoint. And that is very complicated. However, it's solved. It's not impossible. Now, we also have identity management solutions for proofing, validation, and verification. So we solved that one. Then we did the clearinghouse. Like I said, there is nothing clear about a clearinghouse, people. Check my blog out. I even called it clearinghouse as an oxymoron. Payments. Believe it or not, people got to get paid in this industry, and they get paid somewhere, but a lot of people don't know where, which is one reason we want to use a blockchain. One of the provider systems, and I shall not name them, they said, well, I said, all you have to do is put your merchant ID in the field. And they said, that's impossible. It took them 2 weeks to find their merchant ID. They put it in, we deposited 1 cent, and it came up in their account. They said, that is amazing. That's a true story. Financing. So all of the stuff on that side, what we call the rails, we're just going to, we feel we can give those things away. But at the end of the day, PokitDok is a machine learning and AI health company on the chain. And one of our first data products was compute the probability that the consumer could pay for that service. We did a huge probability graph model because we have all the data over here. We also compute the ability for the provider to get paid from the payer. We risk pool. And I can tell you, boys and girls, that the fintech companies love that one because they can pay it down at a 45% reduction, same-day self-pay. So what we did, we fused it all together. And we made third-party APIs. We have about, we got about 1,200 third-party applications. We power about 90% of the telehealth world. Sequenom, LabCorp, Xerox, several really cool companies out there. Check us out, platform.pokitdok.com. We do several hackathons. All our documentation's open. It all returns that JSON stuff. And we think in very graph theoretic formats. This is actually a legitimate query model that starts with claim status and goes all the way from provider to eligibility to pharmacy formulary and back up to Jane Doe's scheduling time. So at the end of the day, the business goal for health is the probability that somebody's going to get paid. So the probability, given that dollar sign, and I'm going to use the dollar sign in a very liquid format here. I'm going to say asset under consideration because what if we had a barter system here? What if there's a disaster recovery situation, somebody wants to go to Haiti and log their time? What if somebody wants to have a coin offering and there's a different valuation on that asset? What if somebody wants to give a piece of land for a health service? So the ICD, that is an internal designation for the code. So if you're in the hospital, they got a code. If it's external, it's called a CPT, and an MPI is the number given to the provider. So the combination of the asset given those numbers is how much somebody usually gets paid, and that's the entire business of health. Now, everybody would like to know where I think by 2020, we're going to have a $5.6 trillion spend in the United States. That's not globally. We computed the other day some values, and I'm going to get to that in a minute. We computed $650 billion on the back of the envelope could be taken out. That's massive. So, what does this revolve around? It should read stored procedures, not stored procedures. In health, and this is another thing I was aghast about, 80% of all rules are in stored procedures. Why? Because the devs are lazy and nobody cares. We shouldn't have that at this, with the type of technologies that we have available to us. That shouldn't happen. So what are we going to do about it? We're going to take those stored procedures out and we're going to put them in smart contracts. We believe that there should be multiple chains, multiple technologies, and multiple types. The top lollipop behind me is research. We have to have genetics and cancer research. They have a very special need for chains over and above any of the business aspects. The personal health record interacts with the consumer, which is C sub N. P sub R is the payer, BK is the bank, and PY is the provider, and EM is the employer. So you have a benefits, finance, and personal health record type of chain. Multiple chains, multiple technologies. So what do we think? At least we believe that the essence of all this, if you pull the rules out, because once again, we're looking at how these enterprises, because we have about, like I said, I think we had about 1,200 third-party applications right now. We're looking at all of those transactions across all of those rails, and we're learning the rules right now. So we're pulling all of those rules out on all the data, and we're building smart contracts. We believe that, if most know, this is very basic stuff. Representing events which trigger that logic as messages to the respective programs. You don't need a chain for that, but it's really nice. You could a lot of these applications. You could take Cassandra and put it on top of Kafka and be done, right? But the essence of what we are trying to do in a business relationship across a multimodal jurisdiction between health and finance, the smart contract is the essence. So a permission system, we're looking at a private chain. There's a lot of, we have to get the enterprise working first. Remember I said that the health industry is having problems saying API. We got to get that across the fence first. There is going to be a layer out to the consumer. We must consider per asset permissions. Like I said, we are looking at multi-asset issuance. So coin, multiple dollars worldwide, even real estate, even barter for time. And interoperability by design. If we pull those rules out and we think of ways in which we can consider smart contracts as the interoperable solution, we can all agree on a reduced rule set. One of the things that I hear over and over from the health enterprise world is it's too complicated, it's too hard. Well, that's not a reason, that's an opportunity, right? The banking industry is very interested in this, in the industry, and all they want to do is do a card swipe. They want to reduce that rule set. And something that I believe, having worked at technology companies, I also did technology policy on the Hill for a company called Microsoft for about 4 years. Please don't regulate technology. You're never going to beat it, and it's going to you're squish the balloon. It's going to squirt out somewhere. So we believe the asset is a function of the rule set based on the context. Context is extremely important here. The semantics of the computation is very important. If anybody's ever is a fan of Turing, or what he was trying to say, he said 2 + 3 = 5. 2 + 3 is semantically different than the compute of 5. We believe that for the smart contract as well. The rule sets, as I said, can greatly simplify the computation. And the rule sets, and this is important, we believe that they are executed via higher order agents. Both the rule sets and the assets are the asset under consideration. Once again, that AUC. The compute at any given context is going to change the asset possibly at write and read time. So you can have a smart contract that's executed. It changes. It's going to self-amend. We believe there's going to be self-amending contracts that's going to do another compute and rewrite that asset. So to give you a great eye test here, this is some of the stuff that we have to deal with. The stuff on this side over here is called ASCII, is raw ASCII 5010. It is a 1970s standard. There are people that can read this. I shake their hand. You know, I thought I was good back in the day when I used to use MaxBug and read hex codes and decompile everything. The right side's JSON, okay? There's another click, and that's a smart contract. But I just want to give everybody a level set for how ugly this stuff is and help. Patient-centered transactions. We executed the first production-ready eligibility check last September, on 2016 in health. We pulled an Ethereum fork. Just for everybody's edification, we're running on both Ethereum and Hyperledger Sawtooth. We got some announcements coming out in the next couple of weeks that's going to blow some people's minds. But here's how it works. This is a real eligibility check. So you walk into the doctor's office and say, I fell down the stairs, doctor. I need to check my eligibility for a pair of crutches, and to see if you can see me. You check the insurance. It writes the token to the eligibility, executes the smart contract, and then we send it off, and we do a side chain. And you could store it in IPFS or IPFS with IPLD, nice AMI, spin that up, pop it off, check it, comes back. The provider says, okay, I am here to see that person. You know who you are, I know who I am. We walk in at the given time, it's geolocated, we pop it off, and we check it. So why is this important? I threw this in here because we're at Rice Business College. Hopefully they teach game theory at Rice Business College. I'm a big fan of Johnny von Neumann. It's a study of mathematical models of conflict. Most of life is conflict. I started off with the first slide saying, hey, can't we just get along? The cooperation between intelligent, rational decision makers, rational being the operative word here. That's the problem. So, what actually happens? Given a smart contract, we inherently have a negotiation situation. You want to buy A? I'm going to give it to you for B. No, you're going to give B, I'm going to give it to you for C. Negotiation assumes strategy around choice. This choice can be based on a utility function, usually convex utility functions. These utility functions are what we attempt to optimize. Optimization includes equilibrium states within the system. Is everything okay? Equilibrium states assume agreement between two parties. So everything's going to slosh back and forth until we get to an equilibrium state, right? Negotiation can be accomplished with software agents. So most of people are familiar with chatbots nowadays, but PokitDok is especially big on software agents. We feel not to be confused with these type of agents. Maybe I should sell this house and I think this is hilarious. I'll be the real estate agent. I said, maybe. There's a negotiation. A good real estate agent doesn't know the meaning of that word, right? And I love this. Pack your stuff, escrow closes, we're out of here. So that's kind of the state of the industry right now. Everybody's trying to clamor around what's actually happening in this world of blockchain. But escrow is already closing, folks, right? A lot of things are happening. There's going to be huge disruption. So literally what happens in these agent-based systems? What's my time?
We're right at time. Maybe just a few more minutes.
Perfect. Yeah, so connecting, dealing, and exchanging. So an agent is a computer piece of software that makes a decision for you. That's scary, huh? It's going to make a decision for you based on an optimization function. Agents address the effective rule sets. Remember I talked about rule sets all the way back to the SQL database. We're rewriting those rules. Agents can represent per asset or per contract. We've written several blogs recently on genetic programming. That was made famous at Stanford a long time ago, and we see it coming back. We're doing a lot of work in that area. So given we need the contracts to self-amend, this predisposes us to what we believe, and this is what we believe right now we're looking at. We just hired one of the main committers to Tezos, professor from Bucknell. His professor invented COQ and some of the OCaml stuff. We believe that we have to have a non-Turing language, and especially for health, because there's got to be a DSL associated with that analysis. This is going to add a level of complexity, of course, but we see a lot of hardware coming out for that. And we need the computational models to be abstracted for the DSL. We think this is what the model looks like. It's a basic exchange and execution market. And then for the health inclined, we believe that the EMR is going to be a node. We believe that the personal health record is going to be dynamic. It's going to be a vector of data that changes based on the context and compute of the smart contract. And these silos are going to be broken down. And so what that leaves us with is a behavioral agents at the top, essentially stat, arb, and health, because remember I have all the prices as well. We want to create a true stat, arb, quant, market, and health. An SDK and a DSL for all the smart contracts, and then putting on top of the blockchain infrastructure. I could have put all this stuff and not said anything to anybody because I already have all the third-party applications running. I could have just slipped blockchain under, but what fun would that be, right? So some of the near-term and future considerations, electronic medical record systems are going to be a node on the chain. Most of the pain that you feel, hopefully, besides a real broken leg when you go to the doctor, is the fact that EMR is busted. We feel it's going to be a node. Guardian Insurance just invested in us, and they want to do dynamic underwriting in real time. We think that's coming. Clearinghouses will be disintermediated. We're going to disintermediate one of our own technologies. It's a Trojan horse. And then complete systems will be on a chip. Sawtooth Lake Technologies are well on the way. There's some other chip companies out there that are going to be announcing soon, and I think that we're going to have FPGAs and Verilog implementations by the end of this year. We announced a alliance. It's a DocChain Health Alliance. It has companies like Amazon, TransUnion, Ascension Health, PNC, MasterCard, tons of companies like that. The next meeting is June 13th. You can go to docchain.com and sign up. And that's all I got. Any questions? Okay, cool, thanks.
So just for everybody's information, we'll have the speakers in the classrooms for the next few minutes. We'll also have the social beginning in just a little bit. So everyone is welcome to join us for some refreshment and a little bit of food. And then the weather is so nice that we'd love to have everyone outside under the tent enjoying each other's company, and that will last until about 7 o'clock. The classrooms that for the question and answers, that's 214, 216, and 312. 312 is going to be the third floor. And then just a reminder that we'll kick off tomorrow at 8 a.m. So look forward to seeing everyone back tomorrow. Oh, quick question. There'll be signage outside.